Okay, welcome back to the next latest and greatest webinar on CIS-211 here at GMC. I am Professor Lesby, and I would like to do what I've done every week up to this point and go over what it is exactly that you need to do for week 7. All right, I assume everyone is very comfortable with the classroom at this point, the most important link being this virtual desktop that has everything we need installed. All right, so if we go down to week 7, we're going to see that this week's a little bit different and that there's 2 chapters that week 7 covers, and we already covered quite a bit of it in week 6, chapter 14 anyways. All right, and I believe that we talked about cues up here, and then down here we're going to start to talk about stacks. All right, so that's why we're covering chapter 14 again, 2 very important data structures, as well as chapter 15, which goes over big O or runtime analysis. And just to clarify, I also had to dig in a little bit. The week 7 quiz covers chapter 15 only. All right, keep that in mind. Week 7 quiz covers chapter 15 only. But let's take a look at this one at a time. So in your book, chapter 14, yeah, we've already started looking over that, right? We were talking about cues, and this week in chapter 14, we're going to start to talk about stacks. And in chapter 15 here is all about big O analysis. And the idea behind big O analysis is that, well, what if we have 100 different algorithms that all do the same thing? Which one do I pick? Right? If they all do the same thing, they all create the same output, they all sort a bunch of numbers, well, who cares which one we pick, right? They all do the same thing. You can close your eyes and throw a dart at the board and pick whatever the dart hits, right? Eh. All right? Because each of these solutions have a different complexity. Some use a bunch of loops, some don't use a bunch of loops. Some use some very advanced data structures, some do not use very advanced data structures. And at the end of the day, you want to do big O analysis and find the solution that has the best worst case runtime complexity. That is what industry is going to expect. All right? Because in the beginning, when you have a few number of items, you can pick whatever algorithm you want. However, when you go to scale up in your Google or your Facebook or whatever, they do expect your algorithm to run just as good as when you had a few items. It needs to be scalable. And algorithms and data structures that have good big O times are scalable. Algorithms and data structures that do not have good big O times are not scalable. And they will fall flat on their face as soon as the amount of data starts to increase. All right. So that's why this runtime analysis is so important. It enables you to pick the right tool for the job. All right. All right. So at a high level, that's what chapters 14 and 15 are over. For week 7, for the week 7 quiz, they're not very clear about this, but this does cover chapter 15. You will have 10 questions, 25 minutes to take it, 1 attempt at the quiz. It is due by Sunday at midnight. All right, so make sure that you study and are comfortable with chapter 15 before taking this quiz. All right, what else do we need to do? Excuse me. The programming assignment. The discussion. And a lot of you have already started the discussion, and it basically wants us to complete programming activity 1 in chapter 14. Well, what the heck is programming activity 1 in chapter 14? Well, if we look at chapter 14 here, here's programming activity 1, and it wants us to focus on a stack class. All right, we learned about the queue class. Well, there's another important data structure called a stack that basically, and all of these different data structures have what's called the CRUD behaviors: create, read, update, and delete. All right, and the stack has a push or the create and a pop or the delete. And the way a stack works is in what's called LIFO behavior, last in, first out. Okay, the exact opposite of a queue. So if you're the last one in line, you get service next, right? I'm sure people at the grocery store would love that, right? So they basically want us to take the stack array class and implement that LIFO behavior in push and implement that LIFO behavior in pop. And for push, well, that basically means you're going to take the new item and you're going to insert it into the tail end of the array or the list. If you pop, you're going to pop whatever that tail item is. Or the reverse. You could say you push on the top and you pop off the top. All right. That is the idea of a stack. All right. So, all right, how do we go about completing this? Well, we go to the remote desktop, right? We launch NetBeans, and we should see something that looks like this. We create a new project, Java application. Give it a nice descriptive name. We do not need to create the main class because these files are available in the textbook. So make sure these are both unchecked. Keep this as the same location. Nice descriptive name. Click on Finish. All right, and we have a nice empty project here. Now we want to go into the classroom inside of the virtual desktop so that we can get to here, textbook activity framework files needed. Let's go ahead and click on that. And let's go into chapter, I think it was 14, right? Programming, was it 1 or 2? We are on programming activity 1. So let's go to programming activity 1. These are the files we need. All right, let's minimize this. Let's minimize this. Let's go into NetBeans 8 and let's drag and drop. Hold down the left mouse button and release right on top of the default package. That adds the files we need. And if we look inside of stackarray.java, we'll see that they haven't, right? They tell us what to do here. They have some nice pseudocode requirements here, but I do need to know that, well, this is for the discussion. So how do we go about creating a solution to this? Because I would like you to discuss that and learn from this. Well, before this webinar, I created my own project based on programming activity 1 in chapter 14. And this is what I came up with. All right, so remember that when we push on a stack, first of all, we need to make sure that we are not beyond capacity, that the top is less than the capacity. If that is true, then that's fine. You can go ahead and add to the top, add 1 to the topmost index, and then push that value on top of the stack array at that top location. All right, so notice that this code here is making sure that there's enough room to push it onto the stack, number 1, and number 2 is incrementing that top index pointer so that we know where to put the actual value. All right, now capacity, well, what the heck is capacity? We see that capacity is defined up here at the top. And for this particular application, it is 10. All right, so for the push, make sure it can hold it, increment the top index, and then stick that value wherever that top index is in the stack array. All right, what about pop? Well, pop means that we want to remove an item from the stack. And in order to do that, first thing we need to make sure that we we have some sort of item on the stack. So that's what this is doing. Look at that top index pointer. Is it greater than -1? If it's greater than -1, for sure we have some items in the queue. So if this is true, we have items in the queue, and we come down here to line 72, and 72 says, all right, we'll go to that top index location, grab whatever value is at that index in the array, and store it into a variable called pop item. Go ahead and remove one from that top index because we just grabbed it. We're popping it from the stack. We just grabbed it. And now I want you to return whatever that value was at that location in the array of the stack. So here we're checking to make sure we have items in the stack, and we are returning the value at the top location of that stack and subtracting one from the top. Now, if top is not greater than -1, well then there's nothing in the stack, and that's why this exception here is thrown. Okay, and if we run this, it should look something like this. And notice that we can continue to push all the way up until boom, right? We've reached the capacity. We can continue to pop, and notice how the top index pointer changes. We can continue to pop until we hit the bottom and there's nothing in it, and we cannot pop. All right, and that's the way a stack works, right? If we push 1, we push 2, we push 3, but when I do pop, it's going to pop the last one added here, which is 3, and then 2, and then 1. So last in, first out is the stack's behavior. All right, so in the discussion, kind of, discuss the push and the pop behavior, as well as these questions here. Yeah, there are some big O runtime questions, and that comes from chapter 15. All right, the actual programming activity has to do with a stack, but now you should know the difference between a stack and a queue, and you should be able to speak intelligently about the difference between a stack and a queue. Yeah, and that's that for the week 7 discussion. All right, so what else do we need to do? The week 7 programming assignment, which is, here. And yeah, not a lot to it. It's basically just saying, hey, create a stack that will store the following data using 10 push. And here's the data, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then once you've pushed all 10 values onto the stack, call pop on that stack 10 times. And when you call pop on that stack, it should produce that sequence backwards, right? Instead of 10, 9, 8, 7, 6, it'll produce 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. If we were to use a queue here, it would be the reverse. So this assignment's testing you on a couple of things. Number 1, can you create a stack object? Number 2, can you use this push and pop operations? All right, so how do we go about doing this? Well, we go to the handy dandy remote desktop like we always do. Let's create a new project. Java application. Let's give it a nice descriptive name. What is a CIS? Okay. We do want to create a main class because we have to write this from scratch. We do not have any files to start from. And leave the default location as is. Make sure this is unchecked. Make sure this is checked. Click on Finish. And we should see a nice empty project here that we can start with. And here is our main method. Well, what the heck do we put in here? Aha, I'm glad you asked. So before the webinar, I took a look at this, and I want to give you some guidance here. So you can use the stack data structure from the discussion. Where did that go? Here, this stack array. You could always import this class and use it in your assignment. Or there is a stack class built into Java, and it does use generics, and we can basically say, well, hey, create this stack using an integer data type, which is a data wrapper around an int. All right, and it's one line of code to create a stack. And then down below here, I'm giving an example of how to push and how to pop from that stack. All right, so it's up to you which way you want to go here. You could always use the stack array implementation from the discussion, or you could just use the built-in stack data structure available in Java. Keep in mind, this is just a demo. All right, here is what you actually need to do for the assignment. I need to know that you can turn this pseudocode into Java code, and when you run it, right now it's just showing the demo stuff, but when you run it, it should produce output that looks like this after you push these numbers here. So definitely you want to take a screenshot once you get this working of the output, show me the proper output and the timestamp, and I will be happy with the week 7 assignment. All right, and the results document, like I said, refer to previous webinar recordings on how to create the results document. But yeah, I do need copy and paste the code, copy and paste the screenshot with the proper output and the timestamp into your results document. And yeah, it'd be nice if you turn in the code as well, just in case I have any questions on that results document. All right, put everything in a one zip file, because I am getting reports that the classroom when I accept more than one file, but it's weird because I do see students that have submitted more than one file. So that's basically it for week 7. Continue to email me and let me know, feedback about these videos. It's what keeps me going. It's what helps me improve them. And if you have any questions, also feel free to reach out to me via email, and I'll see what I can do. Okay, so have a great rest of the week, and yeah, we're coming up on week 8, so if you're behind, now is definitely the time to catch up. Okay, have a great week.